Hello, welcome to this lesson. In this video, we are going to solve this question I have on the screen. The question says an 80 kg block rests on a horizontal plane. Find the magnitude of the force P required to give the block an acceleration of 2.5 meters per second squared to the right. The coefficient of kinetic friction between the block and the plane is 0.25. So let's look at how you are going to solve this question. So this force here is being applied at an angle. So it's going to have a horizontal and a vertical component. So we're going to have the horizontal component to be P cosine of 30 degrees. And then the vertical component to be P sine of 30 degrees. Okay, so we're going to be applying Newton's second law of motion, which says that the sum of forces acting on a particle should be equal to the mass times the acceleration of the particle if the particle is in motion. So you're going to have sum of forces to be equal to mass times the acceleration of the particle, in this case, the block. So for us to be able to solve this question, we must consider all the forces acting on the block. Okay, so I'm going to draw a free body diagram. So this is the block with a mass of 80 kilogram. Okay, and then we have the force P acting at an angle of 30 degrees to the horizontal. Okay, so you're going to have the weight force of the block, and then you're going to have the normal force. And because there is friction between the block and then the plane, we are going to have frictional force F. So those are the forces acting on the block. So first of all, we are going to consider the sum of the forces in the horizontal direction. Okay, so let's look at that. So I'm considering this direction to be positive. So this should be equal to the mass times the acceleration of the block in the x or the horizontal direction. Okay, so let's continue. So for the forces in the horizontal direction, you're going to have the x component of the force P. So you're going to have P cosine of 30 degrees. And then you're going to have the frictional force. But the frictional force is acting opposite to the direction of motion. So you're going to negate it. So you're going to have minus F. Okay, so there are only two forces in the horizontal direction. So this should be equal to the mass times the acceleration of the block in the x direction. And the block is moving horizontally at an acceleration of 2.5 meters per second squared. And we know the mass of the block, so we can do the substitution. So you're going to have P cosine of 30 degrees minus F to be equal to 80 times 2.5. So now let's look at the frictional force. So frictional force is equal to coefficient of friction, okay, times the normal force. And we know the coefficient of friction to be 0.25. So you're going to have F to be equal to 0.25 multiplying N. In this case, the normal force will not be equal to the weight force because it's not only the weight force that is acting on the block. There's another force P. So we can't say the normal force is equal to the weight force. Okay, so now let's do the substitution. So I'm going to have P cosine of 30 degrees, okay, minus 0.25 multiplying N. This should be equal to 200. So this becomes our equation 1. Now let's consider the sum of the forces in the vertical direction. So for the forces in the vertical direction, we have the weight force, the normal force, and then the y component of the force P. So the normal force is pointing upwards, so that would be positive. So you are going to have N. Then the y component of the force P will be negative, so that will be minus P sine 30 degrees. And then minus the weight force, which will be 80 kilogram times 9.81. Okay, this should be equal to the mass times the acceleration of the block in the y direction, but the block is moving horizontally, so it will not have acceleration in the vertical direction, so all this term becomes zero because the acceleration will be zero. So you're going to have this to be equal to n minus p sine of 30 degrees minus 80 times 9.81. This should be equal to 784.8, so I'll make it 785. Okay, so this should be equal to 0. So this becomes our equation 2. So now we want to find P. So for this reason, we are going to make n the subject from equation 2. So I'm going to have n to be equal to P sine 30 degrees sine 30 degrees plus 785. Okay, so you are going to substitute this value in place of the n that we have here. That's in equation 1. So you're going to have P cosine of 30 degrees minus 0.25 multiplying n, which is P sine 30 degrees, plus 785. This should be equal to 200. So now let's simplify this and solve for P. So I'm going to have P cosine of 30 degrees here minus 0.25 times sine of 30 degrees. That gives me P multiplying 0.125. Okay, and then minus 0.25 times 785. That also give me 196.25. All this should be equal to 200. 200, sorry. Okay, so now let's simplify this. So cosine of 30 degrees will be 0.866. You're going to have 0.866 p minus 0.125 p to be equal to 200 plus 196. Let me write this, plus 196.25. Okay, so now let's simplify. So I'm going to have 0.866 minus 0.125. So that gives us 0.741p to be equal to 200 plus 196.25. That gives us 396.25. So now let's divide both sides by 0.741. So this will cancel out this. So let's find the value of p. So that will be 396.25 divided by 0.741. So that gives me a value of 534.75. So I have 534.75. So I'll round this to 535 Newton. So this becomes the value of the force P, which is causing the block to accelerate at 2.5 meters per second squared. Thank you very much for watching this video. Please make sure you like the video and subscribe to the channel.